Hi everybody, this is Mr. Johnson, famous YouTuber, you've probably heard of me. This is a reaction between magnesium and hydrochloric acid. For this reaction, there's three options for what you can manipulate. One of those options is the surface area of the magnesium. This gives you an idea of how you could do that. Each of these three piles has the same mass of magnesium in it, but as you can see, that's one large piece, that's 6 or 7 medium-sized pieces, and that's about 15 small pieces. The more pieces there are, the greater the surface area. Another option is that you could manipulate the concentration of the hydrochloric acid. Here's a flask with hydrochloric acid in it. You could have this at 3 different concentrations, and that would be manipulating the concentration of hydrochloric acid. If you were to do that, you would want to have the volume or amount of hydrochloric acid the same, and then the same mass and surface area of magnesium. A third option is you could manipulate the temperature of the hydrochloric acid. You could use a hot plate to do that and heat it up to 3 different temperatures, or one could be room temperature. And if you were to do that, then you'd keep the concentration of hydrochloric acid the same and the mass and surface area of magnesium the same as well, those being controlled variables. Once you've decided on your manipulated variable, you want to pick your responding variable, how it is you'll measure the reaction rate. One option is to measure the change in mass over time. If you were to do that, you'd be using a scale. You would have the flask on the scale, being really careful not to spill anything. We don't want to get that scale wet. You could zero it before you start. You won't have to. And you'd add your magnesium to the flask. And you'd have a stopwatch. You've decided in advance how long you want to run this experiment for. You figured that out during your trial run. So you hit start when the magnesium goes in, and as the reaction's occurring with the gas being produced, you're going to see a change in mass. After the elapsed time, you hit stop, record the final mass, and the difference in those two masses would be the change in mass. The second option is to monitor the volume of gas produced over time. This is a gas collection device. Got a stopper with a rubber hose coming out of it, and it's going up into a graduated cylinder that's upside down and that's been pre-filled with water. I filled it with water, put my hand over the top, dunked it into this tub here, pulled my hand out, and then the column of water stays up. You'll see in a moment that when I add the magnesium to the flask, the gas that's produced is going to be going through the tube into the graduated cylinder, and the column of water, as that gas displaces the water, is going to be dropping. You'll know then how much gas is produced by the drop in the water volume level, and the graduated cylinder can be read upside down to determine that. So let's get this reaction going and see the mass changing, and then we'll see the gas being produced. Again, you'd have a stopwatch, decide in advance how long the reaction is going to happen for. At this point, you'd hit start. Mass is dropping. Again, if that weren't what you were doing and you were collecting gas instead. Volume of water is dropping. That's indication of the volume of gas being produced. Good luck, everybody, and we'll see you on the other side.